So this talk is about what new things we introduced with PXC 5.7, and mainly to kind of showcase what new things have been there. There are kind of a lot of new improvements with respect to performance and trackability. So we'll see what all things are there. Let me introduce myself. I'm Krunal. I am a PXC lead at Percona. So I've been leading this efforts of developing the product with my team. Okay, so agenda for today, we would be doing a quick intro to PXC, assuming that everyone will get on the same page, and then we will straightly jump to what's new in PXC, and followed by performance improvements that we have seen in PXC. And of course, at the last we will throw the session open for everyone to go ahead and have question and answers or discussions needed. Okay, so PXC as a technology, we all know basically it's a multi-master solution wherein you can actually go ahead and write to any nodes of the cluster. And that effectively means, you can write to any of these nodes, and the data or the transactions that is written will be replicated to the other nodes of the cluster. Okay, so that's what a multi-master solution means. So second is it's a synchronous replication. So whatever you write on any of these nodes, it immediately gets replicated to the other nodes of the cluster. So before the commit is communicated back to the application, it is already replicated on these two nodes of the clusters. And importantly, they are free to go ahead and apply that particular transactions at their point in time. Automatic node provisions. So with automatic node provisions, we actually means that if any new node want to join the cluster, it should be seamless. So you can just have a boot the node pointed to the cluster, and then it will boot up and it will start joining the cluster. So that's a very important aspect from a perspective of a cluster. You can join a new node within a few minutes or time, whatever it takes for SST to happen. So IST effectively means if your nodes goes out of a cluster for a short period of time, it can rejoin the cluster by just getting the missing write sets or missing transactions from any of the nodes of the cluster. Okay. And the consistent view of data, this has been one of the most important aspects of any multi-master solution. Wherever you query any of these nodes, you should be able to see the same result for the given particular query or the data point, right? So this has been one of the important things that PXC offers. It offers you a consistent view of the data. Beside this main things, there are PXC can be used in geo-distributed cluster. So you can have one PXC cluster sitting in one data center and other PXC cluster sitting in other data center, and they can talk to each other. That's fine. Compatible with master-slave setup. So if you have a traditional master-slave setup, you can use PXC as a master also, or you can use PXC as a slave also. So that's fine. That works. Read-write scalability. So with respect to read-write scalability, if you have a non-conflicting workload, then you can actually go ahead and have those workloads run on different nodes of the cluster, and you can read parallelly from all the nodes, and you can write parallelly on all the nodes, right? Unless they are not conflicting, that's the performance will scale because you can write at same point in time. So this is the basic things about PXC. With that in the background, I would straightly jump to what's new in PXC 5.7. So how many of you guys have used PXC before this? Okay. So let's see So what we did with PXC 5.7. So we did PXC 5.7 GA 6 months back. Okay. So PXC is now a 6 month, or PXC 5.7 is a 6-month-old baby now. We did a GA in September when we went for Percona Live Amsterdam. Since then, we have been continuously releasing the things at a regular interval, and have been adding a lot of new features to the PXC. Mainly, at every interval, we have been adding features and also doing bug fixes. So our current latest release is 5.7.17, 29.20. There are two 5.7.17, but this is the latest one. The major version will change. And this release is what we will be talking about at this point in time. Okay, so of course we introduced PXC-strict-mode. So whatever things I'm talking about is whatever we introduced in PXC 5.7 since compared it with PXC 5.6. So we introduced PXC-strict-mode. We also call it cluster safe mode. Okay, so the idea behind this was there are a lot of experimental things that are available, or I would not say experimental, I would say workload or statements or things that are not suitable for multi-master environment. Okay, so which works with single node things if you use MySQL server or Percona X server, but they are not suitable for multi-master environment. For example, MySQL engine, right? It's anyway fading out even in MySQL now, but the problem with MySQL engine is it's non-transactional and you can't roll back anything. So anything you have to do with MySQL, it actually is a problem, and it's already an experimental feature in existing PXC2. So we said that okay, let's block this by default, because most of the time people do these changes and they end up making their cluster inconsistent. So so that's one. Then bin log format has to be row. Again, things are getting replicated. You need to have a consistent view. Statement based is completely relative. So bin log format has been made sure that it is always row. DML on the table without primary key. So basically, you have a table which doesn't have a primary key. It's difficult for it to recognize any particular entity across the cluster uniquely. So DML on table without primary key, we don't allow that. As in, okay, well, I will talk about what they mean by not allowing it. Local locks, anything which is local to a given node of a cluster is not good for PXC or for any multi-master environment. Create table as select, since it is actually a mix of DDL and DML. So create table as select is also another thing which is not good from a multi-master perspective, because you can't roll back DDL. DDL are still non-transactional. And local operations. So if you do alter, import, discard, or any other local operation, those happens with file systems. So it is local to that node. And if you try to replicate it, that other node will be inconsistent state. You will discard a table on this file node, but the other node will still have that table and active. So with that, we thought, okay, well, to avoid user running up into errors, we introduced this PXC-strict mode, which can take these 4 values. Default is always enforcing. If you try to use any of these experimental features, you would see that we will block it by raising an error. And then there is a mode which is master. A lot of people do use PXC as a single master mode, and rest of the nodes are just replicating slaves. In that case, your write workload is going only to the single master. And that case, you can still go ahead and use master. We will block everything except the locks. So we can allow locks in that case, because locks are local, and when you get a replicated transaction, if there's a conflict, then it's a problem with applying of those locks. Permissive, in this particular case, we make sure that it's similar to enforcing, except that we don't generate an error, we generate a warning. For all the cases, you will get warnings. It will be on the screen, and it will be also logged into the log files. Disabled, this is something similar to 5.6. So in disabled, it's no warning, no error messages. You can use it as it is. We still recommend all our users with 5.7 to switch to enforcing, so that your cluster remains consistent. And our testing results has shown that by avoiding these experimental features, we did a random testing. You should be able to maintain your cluster pretty well in a healthy state. So this PXC-strict mode was introduced, and I just a quick look at how the error messages or warning messages looks like. So you can see that basically I'm trying to insert a row which doesn't in a table which doesn't have a primary key. So it says without an explicit primary key with PXC-strict mode equal to enforcing or the master. And same goes, I'm trying to alter this table T with engine MySQL. I'm shifting it to a non-transactional storage engine. That's also a problem. And this I am running in permissive mode, so it gives me an error saying that this is just a snapshot. I haven't captured the complete MySQL here, and strict mode is equal to permissive. So, but it still allowed it. You can see that it just raised a warning and it allowed it. So this is what PXC-strict mode is. You can imagine it to be a cluster safe mode. By running this, you will be able to make sure your cluster is more consistent with the data. Next is PXC plus PFS, performance schema. Just now we were looking at Thomas, talk where they have been emphasizing that there has been a lot of gain that we have been seeing from PFS, and PFS is one of the most important aspect moving forward to monitor your systems. A lot of things are being moved into PFS. So PFS or performance schema is already there in MySQL. It has been implemented since 5.5, but unfortunately with PXC, PXC has its own set of structures or mutexes and condition variables. Not all of them were exposed through PFS. So and then especially, okay, all these things are called instruments in PFS terminology. So threads, a lot of these threads were not exposed. Locks, condition variables. So locks and condition variable, not all of them were exposed. In fact, threads, nothing was exposed. File was not exposed, okay? Stages was exposed, but then they were confusing. So the stages that a thread or a particular PXC execution passes through. So we made sure that as a first cut goal, we made sure that all of these things are, whatever is present is exposed through performance schema. Now, how do you make use of it is a second part, but that's the first a goal that we had, that we want to make sure that everything is exposed through performance schema. And mainly, again, why people do use PFS is for monitoring and then tracking bottlenecks. I will show you an example, not a direct example, but then when we did this project 6 months back, this was a Kickstarter where we realized that, well, PXC is not performing good because of these reasons, and then we eventually took a call that we need to fix our PXC performance, okay? And then you can always have alarms or something of that configured so that you can get notifications of what's going wrong in PXC. Okay, so that's performance schema. This is a quick, again, a snapshot just for purpose of showcase. If you're aware of PXC, it's actually stores the data in Gcache when it's replicate the data. That's a local cache where it stores the data. And the Gcache is a consistent file get created at the start when you first time boot the server and remains for lifelong. These are overflow pages. If Gcache is not enough, overflow pages get created and they are short-lived. Okay, and most of the time this information is only present in log file, and parsing log file is difficult, okay, if you want to create some alarms or you want to look into the things. So this complete thing is now exposed through performance schema. You can see that there are overflow files information that is captured here. Same way, this is I'm just an example of threads that there are multiple threads in PXC, and some of these threads are short-lived. If the typical like SST donor thread, right? So SST donor thread will come into picture only when first time you do an SST, okay? And that particular thread is short-lived, but it's important because you will understand that, okay, this particular node is acting as a donor node, and there is SST donor state active for it. So that can be tracked. So there are a lot more things to come in performance schema front from PXC perspective, but this is just a start. We wanted to make sure that we first expose all the data. How do we use it, and how do you tune it, and how do we make more efficient use of that data is something which is going to flow. And a lot of these use cases will come from user trying to use PXC, PFS, and figuring out that, well, this is not done or this is not good. And based on that, we take the feedback and look at the use cases. Secure PXC, one of the major goal, I guess most of us are moving toward is making sure that systems are secure. So PXC was secured, as in I would say there are two modes of security. During transit, when you move the data from one point, from one node to another, whether it's using SST, IST, or replication traffic, it's making sure that it is secured is important. Now, PXC already had a mode using which you can make sure that your data during transit is secured. So, but those mode had some problems. They were not fully secured. We exploited some problems with them, and then we decided, well, we should introduce another mode where we've introduced something called as encrypt equal to 4. Okay, and 1, 2, and 3 are now deprecated and will be moved out in next releases. Okay, major release I would say. And encrypt equal to 4 is very similar to a familiar triplet of key, CA, and cert. This is the same way MySQL uses for client-server SSL authentications. Okay, and the good part is with MySQL 5.7, all these 3 files, key, CA, and cert, are auto-generated during Bootstrap. Okay, so we'll see how you can make use of it in an effective way. But then it effectively means that your encryption for PXC can be almost same the way MySQL uses its encryption for client-server communication. Okay, so this was a major important thing. And then the second aspect is at rest, or basically in MySQL 5.7 they introduced encrypted table space. Well, it was good. You have a node, single node, where you can actually have encrypted table space. Perfect. But what if you have another node which is joining in, and you move that encrypted table space to another node? That another node says that I can't read it because for me, my key is different. Node 1 key is different and node 2 key is different. So in MySQL terminology, it's called keyring. So they say that, okay, well, it's different. But we did manage through a product called Extra Backup to re-encrypt this complete table space. So now if you have encrypted table on node 1, whenever a new node join, that table will be moved to that particular node and will be re-encrypted so that node 2 can still use that table seamlessly. So it's completely user transparent, and it's for you, it doesn't matter whether there is a normal in table space or encrypted table space. Okay, so the other important aspect on security is what we did was, I was telling you that, okay, if you need to go ahead and secure your SST and IST traffic, you have to go ahead and set these many options. Okay, now believe me or not, for most of the users, setting this itself is not something which they would like to do. Okay, and if you're a first-time user, of course you will not do this. Okay, and then you will say that, okay, well, if I need to secure a PXC, there are tons of steps to be taken, and we said, okay, well, let's simplify this out. We introduced something called as PXC-encrypt cluster traffic is equal to on. So you set this variable, it will encrypt your SST, IST, and replication traffic. Okay, so what it does is, it in effectively setting this to on, it will try to pass all these variables internally to the server. So user don't need to pass it directly. The PXC will pass it internally through the internal logic. And well, the second thing is users say, I don't want to generate these 3 certificates, right? I don't know. I'm first-time user. I don't know how to generate SSL certificates. I think MySQL did that well. They have auto-generated certificates as part of 5.7. And what we do is, if in case those certificates are there, we will go ahead and use them. If in case you are using MySQL 5.7 and you turn this on, by default, you will have your PXC in a fully secure mode with respect to the traffic that goes between the 2 nodes of the cluster. Okay, so that's a second. So that's another major thing we did. Moving on, we have been listening about ProxySQL a lot in these days, and PXC is one of the a background component that ProxySQL is helping with. And we did a good amount of integrations, as in I would say we made sure that the PXC is fully compatible with ProxySQL. And when we say it's fully compatible, what does it mean? Already ProxySQL can be used with PXC. Yes, it can, but ProxySQL is a generic product. It can be used with a lot of other products. You can use it with PXC, you can use MariaDB, you can use it with probably my newly launched group replications and other products too. But then, for everything you'll have to configure ProxySQL. And we thought, okay, let's simplify this. We introduced a single-step solution. You run the script, and this script will make sure it will auto-discover your PXC setup, okay? And it will try to go ahead and figure out what exactly is, how many number of nodes are there, and accordingly it will go ahead and add those details to your ProxySQL table, okay? So the configuration, which is one of major hurdle for most of the people when they start using ProxySQL, since they don't know what to enter, you just use the script ProxySQL admin, and it will add the things for you. Again, for first-time user, it's very easy. As in, if you want your PXC cluster to run in single master mode, you can say single writer. It will put one node as a single writer or a master, and remaining nodes will be slaves. And either you can do load balancer, so all nodes will be able to go ahead and get the traffic and they can use it. It's easy to configure, set up. There are a lot of blogs, investigation, the reports that has been logged. I will not go into depth of how to use this script. It's a single step script. You just run it and the thing. It will also create users, by the way. It will also create users, application users for you. Okay, and then you can just start your application. Tell that okay, you use this ProxySQL user, and it will start talking to PXC. Okay, beside that, what we also did is, this is one of the use case most of the DBA used to complain. Well, if I want to take my one of the node of the cluster out of the things, and there is a proxy or load balancer involved, the biggest problem is I will have to first go to the node, understand the load, go to the load balancer or go to the ProxySQL or whatever it is, go ahead, change the setting saying that I want this node to turn to off. Then ProxySQL will take few seconds before it will actually go ahead and divert the traffic. And after that, you can shut down the node. So you'll have to re-log into the node and shut down the node. So this was a multi-step process. Okay. DBA says, well, I want a simple solution. I can log into the node. I'm logging to the node. I'm not logging to the ProxySQL. I'm logging to the node, and I want to shut it down. Well, we said, okay, fine, not a problem. You can do that with this new thing which we call as ProxySQL assisted PXC-maintenance mode. The idea is you go to the node, you say that your normal command of systcontrol MySQL d stop, and what would it do is it will not immediately, server will track this, server will get the signal, and server will not send the signal to the server immediately. It will cache it, but it will update the PXC maintenance mode, okay? And it will reflect it. If the default value of this is disabled, it will shift it to shutdown. And the monitoring script which we have in ProxySQL, it will try to monitor, well, the server status has changed from disabled to shutdown, and it will go ahead, mark it offline. So server will not shut down till this particular period which you have given, which is currently 10 seconds by default, is passed. So after it is passed, server will go ahead and shut down the things. Okay, so that effectively means your load balancer automatically knows that okay, this server is going to go down. I am supposed to route my traffic, and it will route the traffic accordingly. So okay, so that's and then there is also, so I'm just talking about shutdown case, and then there is a maintenance case. You can set the mode to maintenance, and you can take the node. You don't take the node completely out of the cluster. You just avoid getting the traffic to the cluster. Okay, so we introduced this as part of the ProxySQL compatibility. Okay, track important stats. So, well, you talk about any product which is high availability, and you will see that you have to track it some way or other way. And most important things is to track some of the important aspects that takes time. So one important thing which we have seen that takes time is IST, right? So when a new node joins a cluster, it needs to get all the missing write sets, and that particular thing could be really time consuming. And when I say time consuming, it literally takes few, this is a very small example, but for real cases, it may take, few minutes or probably few hours. And in that case, your node is non-usable. But the problem was, how do I know how much time it is taking? Because there was no progress monitor attached, okay? As in, if I am a DBA, I need to know, well, how much time it is taking. For any activity that takes or blocks, we think that there should be some progress monitor. So we introduced this progress monitor. Now through show status, you can go ahead and track, okay, well, I am supposed to receive this set, these many write sets, and I'm currently at 475, and 39% of that is complete. So I can keep a track of how long it's going to take, and I can predict when the node will be up and running. Okay, and once the things are done, once you have solved this problem, or basically once the IST is complete, the IST value goes to null, or basically empty, I would just say. So that's one important thing. We introduce a progress monitor for an IST, so it's easy for you to know or predict how much time it takes. Next is flow control. This has been one of the most problematic area for most of our customer. It has been observed that because the node is slowest node, or there is workload increase, sometime your node goes into flow control, and flow control effectively means if the flow control is set, it will go ahead and drop your complete cluster productivity, because your complete cluster goes to halt, I would say. So, there was no good way for user to know whether the node is entering flow control and when it is out of flow control. So we introduced this explicit variable which says flow control, you can track it through show status, and it will tell you whether node is, if it's on, that's the node is in flow control, and when the moment it goes to off, the node is out of flow control. Okay, and this has been far most important reason when most of the people see why the cluster has stopped accepting queries, and because there has been flow control that has been triggered at the back, and most people don't even know that there is a flow control triggered. So this will help you track that. And of course, the concept of flow control is associated with queue. So every node has an incoming queue, or you can say incoming queue, the load it can handle. And these two things which we talk about, as there is an interval that is defined. So this is a kind of setting a threshold. Okay, so if my queue goes beyond 23, flow control will kick in. Okay, and I will say that okay, all other nodes stop taking the traffic because I am getting slower. And if this particular value drops below, okay, well, this is configurable, so I'm just showing in an example. If this particular value drops below 12, after that, it will send another signal saying that open the flow control, now you are ready to go ahead and take the traffic, okay? So this has been one of the important reasons, and now this particular variable or this particular value is visible, but if you go only to log file, and it is, it's if you change it, it's that time you will see it, but otherwise you will miss it. But so we made sure that this is visible through the show status, and you can change it and you will see the value changes. Okay, so this is another important aspect that we exposed so that user can track their system more better. So flow control and IST were two major things that we came to know has been a problematic case for most of the users. Okay, and beside that, if you have, there is a third component in PXC where when you don't have a quorum, when you don't have a full-fledged node, there is something called as GAed, or we call it as a Galera arbiter. I will not go into depth of what it is, but in short, it is not a node. It is just a lightweight process that keeps on telling that, okay, this particular node has a quorum, or this particular cluster has a quorum. Now, GAed is not an active data consumer, okay? So it just gets the traffic, and it takes the traffic, and then, it discards the traffic. Now, if it is just taking the traffic and discarding it, and it's a passive data consumer, then it's no point in adjusting flow control, because when you add a GAed, when you add any node into cluster, your flow control interval get readjusted, assuming that there is another node to take care of. So my existing limits may not be good enough. So it's a dynamically adjusting things. Of course, you can set it, but by default, there is a dynamic adjustment which happens. So a GAed, we made sure that when you add a GAed, there is no change in flow control, okay? Because GAed is not an active data consumer. Okay, so these were three major things that we did to track more status. And then there are logging stages, state changes. So with respect to logging and state changes, there has been a lot of complaints that we have seen from end users that the logging is cryptic, especially when you do SST. We couldn't find out why SST fails or what exactly happened. There are tons of log that flows in. There are wsrep log, that is PXC logs. There are InnoDB logs. It's really difficult to find out from logs what's going on. So we did something. We at least made sure that SST and IST logging is simplified. It was difficult till now to determine whether you have done an SST or you have done an IST. We made sure those messages come very clear, what you are doing, whether you are doing SST, IST, what kind of write sets are being transitioned. So we simplified the structure. We unified the logs. So since SST is done through a extra third-party tool, whether it's extra backup or rsync or MySQL dump, the errors get locked to another file. Mostly when you do with extra backup, the errors get locked to another file, and then user normally sends us error.log and doesn't send us the other file, and that other file is located unfortunately in hidden folder, so user doesn't find it. So we made sure that if in case you get a fatal error, that file is also added to your log files, because it's easy to debug. It's one unified way where you can look out of what exactly went wrong. Because mostly when you do SST, the problem is with the extra backup failing, and the reason is there in the extra backup logs, not in the PXC logs. We improved as I said, we improved and made the error messages clear, and we avoid cluttering. So I said there are tons of things used to get printed, right? Even if you do rm minus rf, we used to print that as part of log file. And if you have thousands of files in data directory, and if you are going to clean them up for SST, everything will get logged. So we removed all this thing, and what we did is, there are users who may be, easy for them to debug it out. So we moved that to another variable. I would say wsrep log debug equal to 1. You set this variable under SST, and you will see whole lot of messages that you now see in PXC 5.6. But if you don't, then it's very simple. You will just see 4 or 5 messages which are relevant for you to understand that SST has happened successfully or not, and that's all. Okay. Unless there is a fatal error. Fatal error will be shown irrespective of whether it's a 0 or 1. Okay. So that's what we made sure. So now your logging is pretty simplified. Sorry. Okay. So logging is pretty simplified in that sense, and it's easy for user to understand if there is a fatal error or not. Okay, and then there is a stage framework. So sometime if you want to ask, okay, where we are with respect to the thread, and first thing we do is we do show process list. And show process list is a very effective tool, I believe, and I have used it daily almost when I debug my things. So it's very important that the show process list show you a pretty well or I would say up-to-date information. So that information comes through stages, and the stages that we initially had, maybe this is not visible, sorry for that. The stages that we had were not up to date. The stages were randomly placed, but then we made sure that the stages are properly placed. You see this in bracket, these are sequence number, they are updated, so you know which transaction is currently getting processed, which transaction is yet to get replicated. So if you talk about it from master perspective, you normally will pass through all these stages. You replicate a commit, you write the commit to the group channel, then you pre-commit the data, okay, and you complete the pre-commit. Your certification has passed. Now the transaction can go ahead and commit itself. Okay, so these are typical stages that you see if you do show process list with now, and you're able to track what exactly is going on with that master thread. And with slave, this become more important, or I would say replicating node, where you will see that, well, my query is getting applied, and most of the time query will get stuck in commit because of some kind of contention, and there's no way, before this there was no proper way to show that out, and now we have that, made sure that, okay, well, the stages are properly updated. So you can say that the stages it passes through, you apply a write set, you say that, okay, it's applied, you commit a write set, we say it's committed, and then you finally do a commit of that write set. Okay, so all these things, we'll start using it well. It would be easy for you to recognize that what particular things are. Oh, okay. So the topic of the day, PXC performance. So this by and large has been one of the most important milestone in PXC history. We have improved PXC performance in range of 3 to 10x. We'll see how, but let me take you through some of the graphs that we have already published through blog post. But let's talk about it. This is with sing binlog equal to 1. Okay, the red line is PXC 5.7.16, and the blue line is PXC 5.7.17. Okay, and you can see this is OLTP workload. We have around 3x increase. Update key, which is a single point update using key or non-key, we have around 10x increase. It was something like 2,000, and now we have around 22,000, more than that, in fact. And it has been increasing, and it has been consistently maintaining even with 1024 thread. So it's scaling well with all these threads. Okay, so this has been a major pain point our customer faced, but unfortunately or so we couldn't get time in past to invest in this. With performance schema up and running, we could look at some of those things and figured out, oh, well, there is some problem going on, and then we invested time and we figured out that, well, there are a lot of problems, and we fixed some of them, and we found that the performance has bumped up from whatever it was to this particular number. Okay, and well, it is not only for sing binlog equal to 1. This is with no binlogs. The PXC can operate without binlog, by the way. Most of the you'll say that, oh, it's a replication. No, PXC will do a stimulated binlog, and it can operate without binlogs. And okay, so the legend got changed, sorry for this, but blue line is 5.7.16 in this case, and the red line is 5.7.17 in this case. And you can see, even without binlog, there has been significant improvement, okay, without binlogs too. Okay, so that is one use case, and so you can see in it's not only limited to enabling binlog. Even if you even if you try to persist the binlog with sing binlog equal to 1, you are still getting the performance. If you try to use no binlog, you're still getting the performance. There is a huge boost that you can see. And then we have this thing with just to compare around with the existing things available in market. And we have this blue line for MariaDB cluster. This is all 3-node cluster, by the way, for MariaDB cluster. And then you can see this green line is for PXC, and you can see there is a yellow or red lines. These are for group replication or MySQL InnoDB cluster. And they have a very high value of flow control. So we tried with 2 different values of flow control. I've recently published a blog of why we shouldn't have large values of flow control. So we actually restricted it to 100 for that same reason. And it was initially 16, but we found that 16 is too low after the performance improvement we got. So we have actually traced this, and you can see that almost either we are on par with group replication or we have surpassed group replication by quite some significant margin too. Okay, so this is with sing binlog equal to 1. So even with persistence, a full-fledged persistence, what we talk about, which is what MySQL 5.7 introduced, we can see that we have been able to scale well and surpass the performances. And this is another thing where sing binlog equal to 0. So that's another use case where I don't want sing binlog persistence to be kept on. And we can see that we are on par or we are surpassing that again as we said that. Okay, so it has been consistently you take any configuration, whether it's sing binlog equal to 0, 1, without binlog, with binlog, all the aspects we were able to make sure that PXC has scaled well on all the things, and the performance improvement has been significant, 3x to 10x performance improvements. That's what we say. Okay, well, this is all good, right? And the graph looks good, but what was the problem? Just in case, what exactly went wrong? So we found 3 major issues. So first issue was, there is MySQL has a very optimized way of doing redo log flushing. Okay, so if you have 10 transactions doing redo log flushing, if the last transaction get chance first, it will flush redo logs for remaining transactions too. Okay, so that particular thing here in this case, there is a concept of commit monitor. In PXC, only single transactions was allowed to proceed at any given point in time for commit stage, and that was blocking this redo log flushing stage. So we made sure that the commit logic is updated, and so that the redo log flushing optimization can be taken care of, and which effectively means that you are doing less fsync, okay, for when you do the flush. So that was the first optimization. Second optimization is with respect to performance. So with respect to group commit, so MySQL has this wonderful technology of group commit. Okay, you give it a batch of data, it will process it in batch. Okay, and you get amazing output out of it. The problem was PXC always send only one transaction to that particular group commit logic. So, well, group commit logic you are not using, because if you're sending one transaction to a logic which is meant to handle thousands transaction or even more than that, you are not using it to fullest extent. And the issue was commit monitor is used in PXC to enforce ordering, as in what order transaction should get committed. Okay, and we found out that group commit logic already does that for MySQL too. MySQL also enforces the order in which the data or the transaction needs to get committed. Right. So with that, so what we did is, we maintain the commit monitoring till the point of time we ask our transaction or to enter into MySQL group commit logic. Moment the transaction is handed over to MySQL group commit logic, we say that, okay, well, we are off. Now we will do an interim commit. We will release our mutexes and let MySQL mutexes handle the commit logic after that, because they have done that optimization of handling multiple threads to do the commits. So, well, this was another major optimization. This also solves the problem of redo log flush in case you have logbin enabled. So both of these issues have got solved when you actually had this interim commit enabled, interim commit done. And now what we do is we have a commit or our mutexes done only for this part of time, and the majority of work which happens here is taken care in parallelism with the existing MySQL group commit logic, okay, which is already optimized. So that's the second aspect of performance that we solved. And then moving down to the third aspect, which is this is explicitly meant for without logbin case, that you have logbin disabled. Okay, so in that case, it is important, to understand that without logbin, there are two fsyncs that MySQL does. Okay, and the second fsync that happens is during when you commit a transaction, and the transaction is committed, and that is the time it needs to persist, because with logbin there is a binary logs to take care in case something goes wrong, but here that's not. So once a transaction is committed in memory and it's only about redo log flushing, still PXC was holding that commit monitor mutex I was talking about till even that point in time. So that we made sure that it goes off because it's after that it's only redo log flushing. The transaction ordering is already enforced, okay, because it's already committed in memory. The transaction is already committed in memory. So from that perspective, it doesn't make sense to hold a commit monitor beyond that particular time, and we already released that. And then the fsync, or basically the redo log flush, the second redo log flush in no logbin case can go in parallel. Okay, so that's the third optimization we did, and all these numbers which you see are from those optimizations, and there are a lot of other optimizations possible. I don't know when, maybe we can do it in due course, but then these were some major problems that we figured out which started coming at the top of the list. Okay, so with that, let's move to the next topic, which is PXC plus PMM. I think you might have heard PMM is our product using which you can monitor a lot of MySQL instances, servers. Whether it's not only meant for PXC, you can monitor your normal MySQL instance, standalone instance, ProxySQL, everything. So PXC and PMM. So PXC is fully operational with PMM. You can monitor it completely. And you can also look at different sizes and all those things. One cool feature that PMM does is it tries to predict based on historical data that how long your node can go down without need for an SST. Okay, so that's a cool thing. You can go to this site. It's openly available, pmmdemo.percona.com. And you can take a look at the existing graphs. There are two clusters running there. It's PXC56 cluster and PXC 5.7 cluster, and you can take a look at how these clusters are running and what kind of graphs they are generating. Okay, so miscellaneous items, simplified packaging. So we simplified packaging a lot, I would say not a lot, but then a lot of small tweaks has been done. So for you to easily handle the packaging things, dependencies has been properly created. 5.6 had some of those issues. One major thing we did is PXC 5.6 used to get shipped into two parts, PXC 5.6 and Clara as a library, right? We removed that. We made sure that PXC as a product come as a single product to you. So when you install PXC, you have everything that is needed for PXC, not the ProxySQL, but you have everything needed for PXC. You don't need another package, so one less package to manage. But it is important because a version mismatch between PXC and Clara library will cause you problem. It's fully compatible with 5.7.17. We do keep on refreshing it. It's based on whenever MySQL releases it, first Percona server get released, and post Percona server we releases it, and we also make sure that it is compatible with Codership. When Codership keeps on releasing their releases, we make sure that we also release it. PXC 5.7 is extra backup 2.4 compatible. So in sense, you are getting the latest things available in market with PXC 5.7. Okay, with that, we reach ends to the session. So I will now throw open the session for discussions or question answers that you have. If in case you couldn't complete, then you can always catch me or write to me, or you can post it on forum. But then if you have any questions, we can take it now. Sure. Okay, so if you have two independent cluster, you can use normal MySQL master slave mechanism to replicate it. That's what it would be. There is also something when people set one cluster in one data center and others cluster in other data center, and you can have all these two clusters combined into one big cluster too. Okay, which we call as geo-distributed cluster, and that's also possible if you want to always keep them in sync. But if you don't want to keep them always in sync, you can use the normal MySQL master slave replication.
So going back to if you split down the graph, so would the latency eventually be have a
if you switch to master-slave replication of MySQL. Okay. Okay. Yes. Yes. Yes, of course. So the farthest node that the write set takes to reach is defines the cluster latency, right? So if it's over WAN and if it's going to take you 200 milliseconds, so every write set is going to take you 200 milliseconds to get committed. Sure.
So how does it handle like simplified and identity updates on two different systems?
Okay, so there is this concept called as certifications. So if you do updates on two different nodes, okay, and if it's for the same particular row, okay, then there will be, if you do it on same node, let's assume you do it on MySQL server or Percona server, there are InnoDB locks that will take care of it. But here there's nothing, right? So it works that as if like, every node works that I have taken this update, they don't commit. And then they replicate the transaction onto the channel. So the next node get it, and whoever is the first to write to the group channel will be the winner. Okay. So if node 1 writes it, then his updates will get reflected, and node 2 update will not get reflected. Then the certification will fail, and the transactions will get rolled back. The N2 transaction will get rolled back. Yes. For whoever is the first to commit will win. XtraDB, as in you mean to say the XtraDB cluster, right? Well, I would say it's a subjective thing, but at this point in time, PXC or the technologies that are based on Galera have been pretty mature, and they have been in industry for a while now, right? So we have this auto node provisioning or geo-distributed WAN, a lot of network stability issues that have been solved. Performance has been solved too, right? So in a sense, at this point of time, if you look at and if you try to compare it, right, it looks like that, okay, you try to put a tick against it. PXC looks to be a winner. And of course, I would say there is another talk which is being conducted by one of my colleague. It's supposed scheduled tomorrow, where they compare Galera, PXC, and group replication, in a single way. And then you can also see what differences they have majorly. Sure. Any other questions? Yeah, Matt. No, I don't foresee any special optimizations just for that. But then we have this select for update anomaly, which blog I published, okay, which is of course there. That's something you can take a look at it as a bug or probably a existing problem. But of course that's there. Yeah. We have a documentation for upgrading from 5.6 to 5.7. It should be pretty simple. And I guess we have got a lot of requests. So maybe in due course, we will either have a webinar or a blog coming up for that. Okay, that's all. Okay, thank you guys. And do make sure you rate the app, rate the talk. Okay, thank you.